Hey, it's me, Miss B, and in this video we're looking at the Unit 3, Lesson 5, Cumulative Practice Problems. So let's dive in, and this is for illustrative math geometry. So this first question they're asking, what is the measure of angle A prime, B prime, C prime, and be sure to show how you got your answer. So A prime, B prime, C prime, that is this measurement right here. Well, this is going to be 40 degrees because these lines are going to be parallel. Because if this is a dilation, since it is in proportion 4 to 2 and 6 to 3, that means that the angles will be congruent because dilations preserve angle measure. Okay, so now let's look at question 2. Triangle DEF is formed by connecting the midpoints of sides of triangle ABC. So this is DEF right here. It's formed by connecting the midpoints. They want to know what is the length of AB, but they've shown us just the side lengths of this new triangle here. So if these are midpoints and they want to know AB, so I'm just going to mark for myself that this is what I am looking for. I do know that since these are midpoints, I'm going to have congruent pieces. So I'm going to mark all three of my various sides here as just being split in half. And what I do know, because these are midpoints, is that each of these little triangles is a dilation of half size of the bigger triangle. So if I'm looking for this side here, I want to use the side that's parallel to it. Because that means we could take this triangle and do a dilation around point C by a scale factor of 2, and it would become the big triangle. So I'm going to look at 3 right here, and this is the number I would multiply by 2 to get this piece here. You can also see that this chunk and this chunk are about the same length, but yeah, we just know that that one's going to be 6. So I am going to kind of circle this number here and say that this is 3 and 3. So I'm going to say A, B equals 6 because AB is equal to 2 times EF, and EF is 3. So there we go. That is my reasoning. And I'm showing my work. It is twice the length of EF, or FE if you want to name it in that direction, but either way. Question 3 says angle ABC is taken by a dilation with center P and a scale factor 1 over 3 to angle A prime, B prime, C prime. The measure of angle ABC is 21 degrees. What is the measure of angle A prime, B prime, C prime? Well, this, my friends, is a trick question because dilations preserve angle measure, so we know the measure of angle A prime, B prime, C prime is 21 degrees, and I can say dilations preserve, just means keep the same. They preserve angle measure. So can't fool us. We know dilations preserve angle measure. I literally wrote it up in question 1. So let's move on to question 4. We are going to draw 2 lines that could be the image of line M by a dilation, and we're going to label them N and P. So line M is right here, We want lines that could be the image of line M by a dilation. Now, I could put my point on line M, in which case it would just be its own dilation, but I'm not going to do that. Um, I just know that any point, um, if it's being dilated by something that is not on the same line with it, it will move the line further away, um, or closer, depending on where that center of dilation is, but it's going to move it to a parallel line. So all I have to do is really just draw two parallel lines. So I'm going to do two different color options here and just one on each side. We just have to make sure that they're parallel, and that's all. So I'm going to label them N and P. And we can just say they are parallel, because that was the important part here. Okay, now question 5. Is it possible for polygon ABCDE to be dilated to figure VWXYZ, and explain your reasoning? So, while all of the angles kind of look the same, we need to make sure we're using the same scale factor all the way around. Because a dilation would apply that scale factor to every single side. So is it possible for ABC to be dilated? So we want to go from this one to this one. And it looks like for most of these, at least when it comes to like this and this corresponding piece, that we would be doing times 2. So we are going to check if that scale factor holds up for every piece here. So that's how I'm going to go through and check. Yep, 3 times 2 makes 6. 5 times 2 makes 10. 4, sorry, I'm going clockwise, or wow, clockwise, counterclockwise, which is kind of just the default math direction. So I tend to, when I rotate around things, go in this direction. So I'm checking all these numbers starting with 3, and then I checked 5 with 10, and 4 with 8 was my next one. That works. So now let's check if 4 was my last one. We're going to check 10 with 12. I don't think that 10 times 2 makes 12. So 10 times 2 is not equal to 12. But the rest work, like 4 times 2 makes 8. So we're going to say no, not all sides have the same scale factor. Or, yeah, scale factor. Because we were checking with a scale factor of 2. Okay, and last question here is triangle XYZ is scaled and the image is x prime, y prime, z prime. We're going to write 2 equations that could be used to solve for A. And so A is right here at the bottom. Now, we're going to use proportions. We're just going to set up 2 different ones. So the first one I'm going to set up is from triangle to triangle. I'm going to say A over 5 is equal to 3 over 8. I have to be consistent, but I like to have my variables in the numerator. So I'm going to say A over 5 equals 3 over 8. And so the basic pattern I was using here was from the small triangle over the corresponding part on the big triangle, and setting those equal. The other way we could do this, and the direction doesn't quite matter, but we can compare within the triangle itself. So I can compare like base to a side and base to a side, as long as I'm being consistent with which one I'm using. So I can say base over side and set this one up this way. And in this case, I would say A over 3 equals 5 over 8. So these are technically 2 different equations, but their result is the same, because either way you would be cross multiplying or multiplying by the opposite by the number diagonally across. So 8 would be multiplying with A, and 5 would be multiplying by 3 in both of these situations, which would give us the same answer. And we don't actually have to solve for A. We just need to write two equations. And this was it for homework 3-5, because the next one I have is for the next lesson. So thanks for joining me. This was Unit 3, Lesson 5, Cumulative Practice Problems for Illustrative Math.